SQS أو simple queuing service أول service نزلت على AWS. So it's the first service that AWS gave us بشكل عام. It was launched in 2006 and EC2 was launched in 2008. SQS, which is today's topic, is a legendary service. It's also one of my favorite besides EC2, S3, and Lambda. Of course, these four are my favorite services. So yeah, but as always, before we begin, we're gonna give like a quick recap, a few things we need to understand, and then we're gonna go in the session. فالأشياء اللي لازم نحكيها اليوم, or the topics we need to recap before we start and talk about, is event-driven architecture, decoupled architecture, monolithic architecture. Okay. So, event-driven or decoupled architectures, you can like consider it the same, but monolithic is the different one. Sorry, monolithic is the different one. So let's do this and delete these. Okay, that's fine by me. Okay. So, what's the difference between these two? Okay, شو الفرق ما بين المونolithic والdecoupled architectures? Of course, they're opposite. So, monolithic architecture basically is you have a huge system. So this is a system which has multiple components. So 4 components, let's say, which is 1, 2, 3, 1, 2, 3, 4. So this, or yeah, there's another, let me close this. So there's another also term, it's called tightly coupled architecture. So tightly, there is a T. So again, I said it's هي عكس هاي, it's decoupled with tightly coupled, decoupled and tightly coupled. Okay, so decoupled architecture or monolithic architecture is basically a system that has components inside of them. So basically like any other system, يعني احنا قاعدين عم نحكي المنطق. Okay, عمي انتي, you're saying that this is a system that contains components, which is aka DAW. It's the whole system is in the word DAW. Like, but the difference is when they're depending on each other. So this, let me remove the line I just entered. So this is dependent أو بيعتمد على هاد, and this is dependent, and 4 is dependent on 1, and 1 is dependent. It's like this thing that all of the systems architecture are dependent on each other. So if you want to like draw it, it's going to be like this, and this with this, and this with an X. So 1 is dependent on 4, and 2 and 3, and that's it. Okay. So let's imagine if one of these components fails. So let's say if 1 fails, and because 2 and 3 and 4 are dependent on 1, وواحد 2 و3 و4 بيعتمدوا على واحد, فالسيستم كله it's gonna crash, راح يوقع. ف 1 is failing, عم بفشل قاعد, it's gonna cause the whole system to fail. Okay, so just because 1 is failing, the whole system is gonna fail لأنه هو عم بيعتمد على بعضه. It's tightly coupled, you know, tightly coupled. This is the monolithic architectures or the tightly coupled architectures. Of course, we've said الإشي الأسوأ فيه إنه إذا خلص واحد وقع كله وقع. Let's see. So we can solve this kind of problem. They designed what's called a monolithic architecture, which is 2 components or more than 2 components. And there's this, like here's 1 and here's 2. And let's change the color. So there's something in between them, which is called maybe a broker, an adapter. There's a lot of queuing service, a messaging service, a notification service. So there's more than one thing. It's not just the SQS that you can put or SNS. There's also something called SME, I think, in AWS. So as AWS SMS. Is it SMS? There's this thing I remember. It's called SME or yeah. No, I forgot. Okay, it's okay. So it's an email service. Yeah, I remembered. Okay, whatever. So مش شرط انه احط queuing service زي SQS او notification service like SNS. It can be any kind of broker يعني وسيط بالنص. Okay, intermediary, something in between to handle these two applications. Okay, so this is the event-driven architecture or it's a decoupled architecture. We're gonna talk about event-driven after this. Okay, so this is the decoupled architecture. So if one fails, it's gonna sorry, not this one fails. I'm gonna put this one. So if this one fails, one is gonna keep sending to the broker or the thing in the middle, and this thing in the middle is gonna keep storing it until this is back on service. Okay, فهذا الإشي اللي بالنص راح يضل يخزن هاي المسجات، يخزن هاي المعلومات أو الأشياء اللي بده إياها يوصل للجهة الثانية عبين ما اللي segment B أو الإشي اللي خرب يرجع يتصلح and it goes back up. Okay, so this is a decoupled architectures. It's very different than tightly coupled or monolithic architecture. The main difference is هذا في اعتمادية. There's a dependency in tightly coupled applications, and there is no dependency in decoupled architectures. And this is very important. We're gonna see it how. Okay, so event-driven architecture is kind of like decoupled architecture, but not quite the same. So, of course, we're gonna take the same drawing. So here's 1, here's 2, and let's draw the third one. So yeah, here's the intermediary between these two. Okay. Okay. So an event-driven architecture is it's gonna do the same function. So it's gonna do this function right here. So A can send to B. An event has to happen in A. So this like an event has to happen in A, like lambda functions. Okay. So if we inserted something in an S3 bucket, it's gonna trigger a lambda to work. So this is an event-driven architecture. It also can work in SNS and SQS. So in SQS, an event-driven architecture, let's say I have inserted something into a bucket, so S3. We're gonna send it to what's called a queue. And then this queue is gonna publish the message to subscribers. So this is queue, which is literally a queue. Okay. So this is an event-driven architecture, something that happens triggered a response that's gonna cause maybe a lambda function to trigger. This is in the lambda session, or for our session, it's gonna cause a queuing trigger, and we're gonna see how. Okay, before we start, is there any kind of question on any of the terms I said? في حدا عنده أي سؤال؟ Okay. So let's go back to our SQS session. Of course, we're going to give an introduction, key features, how it works, long pulling, use cases, and a few benefits. So we said SQS is one of the oldest services that AWS is giving, which is it launched since 2006, and it's what's called a queuing service. So a queuing service, it's like this thing. So we have, let's say YouTube. Let's say just for example, YouTube. And then every time I upload a video, it's gonna send a message to my subscribers, so that I have uploaded a video. فعنا channel YouTube like I have, like my YouTube. So every time I upload the video, it's gonna send a queuing message, not a notification. Because if it's a notification, now we're gonna go to the SNS topic. So it's gonna send like a queuing message that I have uploaded a video. So it's sorry. Let me close this. Okay. So it's a managed service, so serverless, and it enables you to decouple and scale microservices. Of course, event-driven and decoupled architectures are also called microservices. So microservices. It has like a lot of names for some reason. It distributes system and serverless applications, and it's going to offer two types. We're going to talk about them. I don't want to talk about them now. So key features, it's going to give us the ability to decouple, and we've talked about, sorry guys, it's going to give us the ability to decouple, and we've talked about decoupling. It's making two components dependable on each other, not dependent on each other. That's what decoupling means. Scalability, of course, it handles it's not a virtually unlimited numbers of messages per second. It has a limit, and we're going to talk about it. But it is still scalable and wait, there is an O. Okay, scalability. So it's still scalable. Like I think there's 1,000 message per second. So it's still scalable. Like 1,000 is a lot. Like imagine getting a 1,000 message from a person. I'd block him. No jokes. And it's fully managed. You only have to manage the business case or the business logic that you need, and AWS is going to take care of the rest. So what better do you need? Also durability, so you can store the message in across multiple availability zones. There's this thing that's called a dead letter queue and visibility timeout. So let's talk about these two. A dead letter queue, so let's have this right here. Let's imagine that okay, a YouTube channel, and we have uploaded to the queue, and it's right here in the queue, and I want to send it to one of the subscriber I have, and no one from the subscribers is taking it. So of course, queuing service, you have to take it. So this guy has to put up a hand, which is 5 fingers. Sorry about the really messed up hand, and take this message, and like he can do whatever he wants in it. فأنا عم ببعت مسج، ولازم حدا من السبسكرايبر ياخذ هاي المسج، وهو بعدين يتعالج أو يعاملها أو يعمل اللي بده إياه فيها. طب لنفترض, let's like imagine or put a scenario that no one has taken this message and it's been there for like 30 minutes. So it's gonna end up in the what's called a dead letter queue. So this dead letter queue is for messages that are not being accepted by any kind of consumer. Let's say it's a consumer, مستهلك. So they end up what's called in a dead letter queue. So you see here that messages that can't be processed successfully by directing them into a dead letter queue. Of course, why do we need to put them in a dead letter queue? يعني احنا شو فايدتنا? Because it's gonna remove it from the queue and it's gonna make the queue work more efficiently. So let's say now we're sending more messages. So here's the first one, second one, third one, fourth one. And this is like, it has an error, it's not processing very well, and it stays. And it just stays, you know. So this is gonna cause a problem. يعني إذا ما حدا أخذ أول وحدة هدول ما راح يطلعوا. The third, fourth, second, third, fourth, they're not gonna come out or be processed. So this should leave and go to the letter queue. So the second, ثاني ثالث رابعة ينعمل لها process. So that is the letter queue. So visibility timeout, same thing. We have the publisher. So pub, and then we have the queue, and then we have the consumer. So let's also imagine we have consumer 2. So this is con 1 and this is con 2. Okay. So now we've sent a message to the queue letter and it's here, and consumer one decided to take it. So the message went this way. So physically, this message is gonna stay in the queue until this is processed and deleted by the consumer one. فهي منطقيا راح تضلها في الكيو عبين ما يعالجها وهو خلص انه ياخذها الكونسيومر وخلص انه this is mine, I'm gonna handle it, and then he deletes it or accepts it or whatever. فراح تضلها في الكيو. هلا بما انه consumer 1 اخذها ولسه ما لغاها or he still haven't accepted it or deleted it or any kind of stuff, it's gonna end up in the queue. It's gonna stay in the queue even though consumer 1 took it. But it's not visible to consumer 2. Why? Because this is what's called a visibility timeout. So this consumer 1 has 30 seconds to finish and delete this message, or else it's gonna show up again in the queue and consumer 2 is gonna take it. فهاي المسج إذا consumer 1 أخذها وما لغاها or he didn't accept it or delete it, it's gonna re-show up, راح ترجع تظهر عنا في هذا الكيو و consumer 2 راح ياخذها. في فترة you choose the time, maybe 30 seconds, maybe 1 minute, 2 minutes, maybe like 7 days. You know, you can choose your time. Of course, there's a limit on the timing. But the bad thing is, if you put like less time, if you put like 30 seconds and consumer 1 didn't have the chance to accept and delete and process this message, and it went to consumer 2, this is gonna cause duplications in work, and it's gonna like cause a lot of problems in the future. So you should be moderate choosing your times. Maybe like 2 minutes are good. You shouldn't also choose like 7 days. It's not perfect. So let's imagine that consumer 1 took 7 days to process one message. It's gonna like cause a lot of headache and problems. So also خد بعين الاعتبار التوقيت اللي بتختاره لما تختار هاي السيرفيس أو لما تختار visibility timeout. So في حدا عنده أي سؤال? Does anyone have any kind of question on the dead letter queue or the visibility timeout? Okay. Okay. So we have, if you have any questions, please put it in the chat. I'll answer them. So we have two types of queue. We have standard queue and we have FIFO queue. So if you took data structure, you're gonna understand a FIFO queue or a queue بشكل عام and a standard queue. Okay. So the difference is this is provide a maximum throughput. It has the best effort ordering and it's at least once delivery. So it doesn't matter how the message is delivered. So again, we have the producer, we have the queue, and we have the consumer. Okay, and another consumer. So standard queue is just send the message, and this message it either goes to 1 or 2. And the next one, or let me change the color, let me make it orange. Here is it orange. Also, orange can go to 1 or 2 based on the effort, based on a lot of things. As you can see here, based on it goes on best effort ordering, and it gives you at least 1 delivery. So either this or this, so at least 1 delivery. So this is a standard queue. It works normally. You don't have to worry about anything. But FIFO queue, oh, no. Okay, that's not deleting, it's fine. But FIFO queue works on what's called a first in, first out. Okay, so this ensures that the messages are processed exactly once in the exact order that they have sent. So you can, in standard queue, you can take this or take this, it doesn't matter. At least it's gonna deliver to at least one person. But FIFO queue, which is first in, first out, let's write this down. So FIFO, you're gonna take this in that structure. FIFO queue, which is first in, first out. So basically, first in, first out is like a queue. Okay, it's a queue, it's not a stack. So FIFO queue, first in, first out, which is منطقيا أول واحد بدخل, like let me try and have my makeup. Okay, you can see there's 3 colors. So there's blue, this is blue, there's pink, and there's yellow. So they come out in this order, which is yellow, blue, and pink. It's gonna be processed this way. It's gonna be processed yellow, and then it's gonna be processed blue, and then it's gonna be processed pink. But in standard queue, if this is the order, it doesn't matter how it's processed. Maybe I want to process the blue one, yellow one, and then the pink one. It doesn't matter, okay? So here, as we said, in FIFO queue, they're going to be processed the way they have entered. So first thing we're going to process is red. And then second thing is orange. And then purple. Okay. This is a FIFO queue. Of course, every one of them has their own benefits. It has their own features, but I don't want to talk about them right now. Of course, encryption, security, we have IAM, so it integrates with IAM, Identity and Access Management, and it provides server-side encryption, SSE. We've talked about SSE and S3 bucket. So it encrypts our data. How it works, literally it works the same way as you can see here. So we have a producer, which is this one right here. So this is the producer. And then we have a consumer, which is this one right here. This is a consumer. And then we have what's called a message lifecycle. So messages are retained in the queue for a retention. Let me remove these. Okay. So messages are retained in the queue for a configurable retention, either from 1 minute to 14 days, or they're going to end up in the dead letter queue. We've talked about this. And once consumer processes and manages it and deletes it from the queue, it's going to be gone. If he doesn't delete it and process it, it's going to end up in the dead letter queue, as we said, which is here. You see, you can have it from 1 minute to 14 days. Okay. Long pulling helps you effectively retrieve messages by waiting messages and reducing the need to constant pulling. So long pulling basically is, I have a producer, I have a queue, and I have a consumer. So as we said, that oh, that's huge. No, I don't want it. So I'll take yellow or blue. Blue is nice. Okay. So, every time I want to have a message, a consumer should pull it, or it's going to end up in the retention dead letter queue, let's say. But this is like a direct pulling. So you have to immediately pull it. Immediately, fast. لازم تاخدها بسرعة. So الفرق بين long pulling راح يعطينا, it's going to give us like a break of 30 seconds. So when the message enters, count 30 seconds, let's say. Seconds. And then after the 30 seconds, the consumer can pull this message. This is basically long pulling. So how it works, it extends wait time. So when you send or receive message request, SQS can wait up to 20 seconds for a message to become available. And this reduces the number of empty responses compared to short pulling, which returns immediately. Okay. And then configuration, it can be configured per request using what's called a wait time request parameter. And you can also set default long pulling. في default, I think the default is 20 seconds. It's not. نحطه له 20 seconds. Okay. So this is the long pulling. You're gonna get after like a short period of time. So use cases. Why do we need SQS? We have a few use cases. We have a microservice communication. We've talked about microservices, and this is a microservice communication. If we went up, this is a microservice communication. So one is connecting with two. Batch processing. We've talked about batch processing a lot. Job scheduling, load leveling. It's going to help us with load leveling and event-driven architecture. So load leveling basically is, I have a producer, a queue like always, and a consumer or multiple consumers. It works like a load balancer, let's say. So Q is gonna work like a load balancer or a load leveler, let's say. Okay, so benefits, it's reliable, of course, it's very flexible, and it's easy to use because it's really, really easy to just launch a queue. It provides high availability and durability by storing the message across multiple availability zones. It's gonna support various of tasks, and it's very easy to use, and it integrates with other services. It's cost effective. You can have pay as you go model, and it's secure. We've talked about it integrating with IAM and SSE, server side encryption. Okay, so we've finished SQS for today. Let me stop the recording. Does anyone have any kind of question before we go to the next topic? Okay, so no questions.